Hey guys, sorry I haven't been there this week. I've been sick. I got food poisoning, so hopefully I'll be back soon. Today I'm just giving you a video to help you do the worksheet. It's not too difficult, so let's just walk through it real quick. In order to do the worksheet for today, you're going to be doing one-step motion formulas, which means you're going to need some formulas, okay? These are the three formulas you're going to be using, okay? What they stand for is if you see an X, that stands for position. Any X you see stands for position. V stands for velocity, and A stands for acceleration. Okay, so that's what all those V, X, and A stand for on all three of these equations. I call these the big three because we're going to be using them a lot throughout the next couple weeks. Okay, so the other thing you need to know is what the subscript stands for. The F stands for final. The O or the 0 stands for initial. Okay, so the way you say this is X sub F or X naught, V naught. Whenever it's a 0, you say naught, like N-O-T naught. Okay, so V naught. So here are your three formulas that we're going to be using. So this stands for final position equals initial position plus initial velocity times time plus a half AT squared, right? This one is a VF squared. So we get this is a VF squared and this is a V naught squared. Okay, I know that 2 is kind of hard to see there. Okay, so I got an example here. We'll walk through this example, and that should give you everything you need to do the problems today. Julian is driving a car beginning at rest. He accelerates for 50 meters until reaching 20 meters per second. How fast was his acceleration? Okay, so I do these problems through something I call the guess method. Why I call it the guess method is it's G, U, E, S. This is an acronym to remember what you should be doing and when. Okay, so the first two letters of the acronym here stands for givens and unknowns. Okay, and that's what you got to do first. So let's label our givens and unknowns. Okay. So our givens will be, you just read through it and you write down anything they give you that would be like one of these variables up here, okay? So Julian is driving a car beginning at rest. Rest means the initial velocity is 0. He accelerates for 50 meters, okay? So that means that is his position. It means it's like his final position, but we can say his initial position was 0. So this is kind of like the change in position, if you want to put it as a delta x, but it's his position until reaching 20 meters per second, so that would be his final velocity. How fast was his acceleration? So let's write down all the stuff that we were given right here. V naught is equal to 0. The change in x, or I'll just label it x, is 50, and our final velocity was 20. Okay. Now our unknowns, we got to find something that's unknown. Okay, so that's what we're trying to solve for. And in this case, it says how fast was his acceleration. So our acceleration is our unknown. That's what we're trying to solve for. Now the next thing you want to do is you want to look at all the things that we know and all the things that we're looking for and look through these problems and see which one has everything you need. So like if you look at this first one, we have XF, it's 50. We have our initial position, it's 0. Our initial velocity we know, but time, we don't know that. So that makes this first one not a possibility. So that is not going to be what we're going to be using for our equation. Then we come to this one. This one also has time, so that's not going to be the one we're going to use. So we hope that we have everything here. So we have final velocity, we have initial velocity, we have we're looking for acceleration, we have the change in x. Okay. So that's the formula. That's the equation we're going to stand for put here, and E stands for equation. Okay. Okay, so it's VF squared equals V naught squared plus 2A. And guys, I know it says delta x, but a lot of times I just write it as x for shorthand. Okay, so then this one stands for solve. Okay, and what that means is solve for whatever variable it is that you need. So we're solving for A. So you guys remember how to solve from the last couple lessons. So if we're solving for A, you'd subtract your V naught squared over. So we'd end up with VF squared minus V naught squared. Kind of skipping some steps here, okay? divided by 2x. Okay, and then all I need to do is plug in and we are solved, yeah? So let's do that. So my acceleration is going to be VF, which is 20 squared, minus my initial velocity, which was 0 squared, divided by 2 times my my change in position, which was 50. Okay, so that's going to be 400 divided by 100. And that's going to tell me my answer of 4. And make sure you put your units. Acceleration is meters per second squared. 4 meters per second squared, and that is how you do these problems. Just work your way through all the problems using the guess method. Make sure to show your work because that's what I'm grading. I have all the answers already given to you, so that's not what I want to see. See you later. Hopefully soon.